So we are discussing traffic studies. What we have covered up till now is why do we do traffic studies, what are the types of studies we can do, and based upon the technique of data collection, we can divide these studies into three types. Okay, we can have manual, semi-automated, and automated. Now, which one are we discussing right now? Manual. Okay. So in manual studies, we have seen problems related to counting. So when you are doing manual counting, then you have to take care of the breaks. Okay. So we saw one example where there was a 3-minute break and there was a gap as well, alternate gap as well. Okay. So we saw how we can deal with these things. And then we moved on to speed studies. Okay. So speed studies can also be manual. You can do it using a speed gun or a speed radar, okay, or you can do it using a stopwatch. Now, if you are using a stopwatch, then we can have two types of errors in speed studies. Who can remind me what those errors are? Parallax. There can be parallax error, which is reverse of the line of sight of the driver. And we saw one example related to that. And the other one, which is what? Yeah. So when we are handling the stopwatch, there can be a delay in your, pressing of the button and the actual movement of the vehicle. There can be a delay, or it can be plus or minus, any size. Okay, but it is random, so we don't have to worry about it if you are taking the average. These are some points which are related to speed studies, and you have to keep them in mind when you will be doing the speed study for your term project. Okay, I'm talking about the second submission now. The second submission, speed study is a part of it. Okay, so while you will be doing a speed study at that time, you have to keep these things in your mind. The first thing is avoid taking data for the fastest or the slowest vehicle. Okay, while you are driving, or if you look at the road, you will feel some drivers are directly out of Formula 1 and they're still in that mood. Nobody told them that you are now on a normal road. Okay, so they are going on their merry way, right? So you feel that this guy is mad. Okay, and then there are people who don't have anything to do in their lives. Okay, just come in front of you and they are, if we are not enjoying our lives, why the others should be, right? So they should suffer with us. Okay, so but the point is, when you see someone who is too fast or too slow compared to the others, you know it, right? Okay, the others are going at one speed and he is way faster than them, or he is way slower than them. Okay, get it? Okay. So, if you see a car like this, a vehicle like this, you don't take its data. Okay, you don't do its recording. Clear? Okay. And one thing you have to keep in mind: this is comparative. Too fast in comparison to others. Okay. So, if you are doing it on a highway, then everybody is going at 100. Okay. If a guy goes at 100 or 110, it's normal. Okay. But if you see someone like this on a street where everybody is going at 50 or 60, okay, then it's not normal. Okay, then you avoid it. Clear? And the other way around as well. Everybody is going slow and somebody is going at 40 or 50, it's normal. Okay, clear? Okay, so too fast or too slow in comparison to others. Why are we doing this? Because these values will disturb your data. Okay. So you have 20 values which are around 50, let's say, and then you have 1 or 2 values which are 90 or 100. Those 1 or 2 values may make your average up to 60. Okay, so we don't want this, and the other way around as well. Everybody is at 80 and you have 1 or 2 values which are around 30. So this will drop your average. Okay, so we don't want to disturb our average. We want the average to be real. Okay, accurate. Okay, which takes care of most of the drivers. Okay, so if there are 1 or 2 drivers, we will avoid them in order to save our data. Then the second point is about a platoon. What is a platoon? Which pass the intersection. Okay. So this point will apply if you are doing the speed study directly after the intersection. Okay. So if you have a group of vehicles which came out of the intersection together. Okay. Now which one has more chances of selecting his or her own speed in that group? Okay, the people who are in the first row, right? Okay. So if you want the representative speed of the road, you'll focus on these first guys. Okay. The remaining are just following. Okay. The remaining people are just following. Okay. But as I said, this only applies to speed studies done where? After the intersection. Okay, because platoons form at the intersection. If you are doing it after the intersection, then you will have a platoon, and then you should focus on the first vehicles in the platoon. Okay, the rest are following. You take them, you don't take them, doesn't make much difference. But if you are doing it away from the intersection, vehicles have not reached the intersection yet. Okay, or the intersection is far behind, it's 5 kilometers behind, then there is no platoon now. Just take everybody you can. Okay, just take care of the first point. And heavy vehicles are normally avoided. Okay, in normal speed studies, heavy vehicles are not taken. Data for heavy vehicles is not taken at all. Okay, unless the study is about heavy vehicles. So I am studying heavy vehicles, so obviously I will take the data. But in normal speed studies, heavy vehicles are not taken at all. Why? They are too slow. Okay, similar to the first point. They will disturb your average, and they are slow because of their size and weight, not because of the road conditions. Got it? Clear? Okay. So keep these points in your mind when for the next task of the project. But we will discuss more in details about speed studies in the next topic, which will start in the next lecture. Okay. So there will be more details as well, but keep these points in mind also. Okay, then we have semi-automated studies. In semi-automated studies, we are using a portable device for data collection. Okay, semi-automated studies are those studies in which a portable data collection device is used. Now, what is a portable device? You can take. Movable, right? So a truck is movable. Yes, movable. Any other explanation?
Is it a carry?
You can carry it. Okay. The chair is movable.
As a
You will
cable.
not take chair and start moving here. You are doing it.
As a cable. You can move it to something.
Anyway, a device you can carry is portable. A device you can carry is considered portable. Okay. A stopwatch is portable or not?
Yes.
Yes, right? So if you do a study with stopwatch, semi-automated or manual? Manual. Why? Portable device, right?
As I use my hand.
Yes. So only having portable device is not enough for semi-automated studies. That portable device which records the data automatically. Okay, in semi-automated studies, we use portable devices which can record the data automatically. In manual studies, you can use portable device, no problem. But we will not call it semi-automated. We are using a counter, but every time the car passes, you have to press the button of the counter. It's manual. But if you have a counter, you just put it there, or you are holding it in your hand, the car passes, the counter counts automatically, it's semi-automated. Clear? Clear? Got the difference? Okay. So, the most commonly used semi-automated device is a pneumatic road tube. Okay. So, as the name suggests, it's a tube. Okay. And this is a tube, black size, very thin, and you may often see it on the roads in Bahrain as well. So you see these two black lines, okay, these are road tubes, okay. Some of you may have already seen them. They put these road tubes on the road. It's very commonly used by Ministry of Works. Okay, so you have the road tube on the road and there's a sensor on the side of the road attached to the tube. Okay, it's always black in color, it's very thin. Okay, I've normally seen, I've just seen one, like they use one at a time or two at a time, that's it. Okay. The main function of the tube is to count number of axles. Okay, the main function of the tube is to count number of axles. What is an axle? It's a rod in the vehicle which connects the tire of the vehicle. Okay, so every set of tire is connected by an axle. Okay, every set of tires is connected by an axle. Okay, so if you have 4 tires, then how many axles you have? 2. Okay, clear? So when the tires cross the tube, the tires are connected to what? The axle. Okay, so when the tube is counting tires, it is basically counting the axles.
What's similar to
Which one? Because you can carry it, you can put it here. You can just roll it and just take it with you. It's like a wire, a very thin wire, so it's very light as well. Okay, you can use the tube for measuring the speed as well. Okay, because then the tube can record the time as well. When was the first axle? When did the first axle cross, and when did the second axle cross? Okay, so using the time and the distance between the two axles, you can record the speed or measure the speed as well, but it will need some calculations. The tube will not give you the speed. You have to do some calculations yourself. You may have to make your own program. Okay, now so the tube is giving us number of axles, and we want what? Number of axles? Vehicles. Okay, we want number of vehicles. Okay. So we have to do something with the value which the tube is given to get the number of vehicles. Okay, so let's say we use the pneumatic road tube for 24 hours. Okay, in 24 hours the tube gave us a value. That value is number of axles. Okay, now if I have to convert the number of axles to number of vehicles, what should I do? Divide by 2.
Some vehicles have more than 2 axles.
Some vehicles have more than 2 axles, right?
Yeah.
We have even the small truck has 3 axles. The small truck has 3 axles. And then we have very big trucks as well, which go up to 10 or 16. Sorry? Who said? No? When did I say this? When did I say this? For speed, it's doing it manually. You cannot ignore anything, right? It's there on the road. Okay, it cannot filter that this was a truck, or it will record everything. Okay, so what do we do at the same location? We take a small sample manually. A small sample manually. Okay, so for example, we have this case where the tube was used for 24 hours. In 24 hours, it gave us a count of 11,000 or so number of axles. On the same location, we did a small manual study. In that small manual study, we were counting number of axles as well as number of vehicles. Okay. So for example, when I saw a 2-axle vehicle, I counted it here in this row. Okay. When I saw a 3-axle vehicle, I counted it in this row. Okay. When I saw a 4-axle vehicle, I counted it in this number, and so on and so forth. Okay, so in my sample of manual study, I saw 157 vehicles with 2 axles, 55 vehicles with 3 axles, and so on and so forth. Clear? Clear? Okay. Now to convert, or the thing which I want is the average number of axles per vehicle. I want axles per vehicle. Okay, axles per vehicle means what? I should have total axles and total vehicles, right? Axis upon vehicle will give you axis per vehicle, right? Okay. From where will I get it? I will get it from this study, the sample. Okay. How many? So I want axis and vehicles both. How many vehicles I have in this study? Tell me. How much? 3 to 1. Sure. 3 to 1. Three or three. Okay, and how many axes I have? Huh? No, this is for the day, the entire day. How many axes I have in these vehicles? 303 vehicles. How many axes I have in these vehicles? Yes? 892. How did we get 892? Yes? Yeah. So there were 157 vehicles with 2 axes. So how many axes is them? 2 into 157. 55 vehicles with 3 axes. So how many axes is them? 55 into 3. Okay. So this is how you will get the axes. Okay, so this is how much? How much is it? 892. Okay, so I have the number of vehicles now. I have the number of axes as well. Give me axes per vehicle. 2.94. Okay, so if somebody divide by 2, he will be underestimating, right? Okay, on average we have 2.94 axes per vehicle, which is yeah, almost. So now I can apply this to the 24-hour count I have. Remember, this was just a sample to calculate this number. So I have 11,250 axes, 11,250 axes, and every vehicle has on average 2.94 axes. So how many vehicles? For 24 hours. Okay, this is the actual count for 24 hours. If somebody took 2 hours or assumed, 2 axes per vehicle, 11,000 divided by 2 will be 5,500 something. Okay, so you can see the difference is large. It's not a small difference. It's in thousands. Clear? Clear? Okay, so that's why we need the study. Okay, any questions? Okay, depending upon the data which you need, how detailed the data you need, you can use different setups of the tube. So the tube itself has a sensor which has to be put on the side of the road, right? Okay. So if you look at the first setup on the top, we have one tube and the sensor is on the side of the road. Okay, and that one tube is going from one edge of the road to the other edge of the road, right? So it's covering the entire highway, both directions. So whatever number you will get from here is for both directions. Clear? If you want a different number for each direction, then you have to use a different tube on each side. Okay, and the sensor again on the side of the road. Clear? So each tube will give you for each direction. If you want more detailed, you want to go into each lane. Okay, so for the first lane, I can lay out the tube from the side till the edge of the first lane. That will give me only for the first lane. Okay. For the second lane, I cannot make it from this edge to this edge, because then where will I put the sensor? So the tube has to be from the side to the second lane. Okay. So it will give me data for 2 lanes. Okay. So I will have to do some deduction here from the first lane to get it for the second lane only. Okay. And if you have the third lane as well, again from the side to the third lane, and you have to subtract. If you have a fourth lane, then same will continue. Clear? Okay. So the number of tubes will depend upon how detailed data you require. Okay. Then we have automated studies. Okay. So again, automated means the data is taken automatically. You are not pressing any button or something. But the difference is in the type of device you are using. In semi-automated studies, we are using which device? Portable device. In fully automated studies, we are using permanent detectors. Permanent in the sense we install them on permanent basis. They are installed on the highway, under the highway, side of the highway, wherever is required on permanent basis. Okay, so you fix them. You fix them. Okay, and you don't take them with you after the data collection is complete. Okay, so they can be under the road, side of the road. Normally, the data which is collected through these types of devices, another name for them is ATC, automatic traffic count. Okay, so if you hear the word automatic traffic count, that means it is fully automated study, and the detector which is used for that is permanently installed on the site. Clear?
Yes.
Okay. These detectors, there are different types of detectors. You can have some detectors which provide speed data, some detectors provide counting data, and so on and so forth. So they are not of single type. There is no single type in them, and they are multifunctional detectors as well. You install them and you can get multiple parameters of the data. They can give you speed and count and so on. Okay. So there are many types of detectors available in this, permanent detectors. The main function of the detector is obviously data collection. This is the main function. Okay. But another important function for them is the transmission of the data. If you are doing it manually, then the device is in your hand, or you are writing it with your hand, and you have the data immediately, right? Okay. With portable devices, the second case, the previous case, you let the device collect the data, and since the device is portable, when the data collection is finished, you will take the device with you to the office and you will download the data. Okay, so you will get the data at the end. Okay, immediately at the end. Okay, with permanent detectors, it is not possible. Okay, that you come after 1 day or 1 month and you take the device with you and download the data. It is permanently installed. Okay, if you keep on doing this, you will damage the detector, you will damage the road, you will damage the side of the road, and so on. Okay, so the detector should have some mechanism to transmit the data in real time. Okay, so just like the speed cameras we have. Okay, so you don't see people coming and unscrewing the camera or putting ports in that. Okay, so it will capture the speed and the number plate, and the data will directly go to the police, right? Okay, so there is no downloading required, there is no connection required, the data goes there. Okay, and some of these detectors can be linked with the road devices as well. For example, a signal. Okay, so there are many signals which are connected to these detectors which are installed under the road. Okay, and the signal timing can change a little bit according to the traffic volume and speed. Okay, so for example, the yellow time is not always the same. It has a little bit of margin, 1 or 2 seconds plus minus, depending upon the speed of the road or speed of the vehicles. It doesn't mean every time you come to a signal, you see yellow, you start going at 200. Okay, it's not always. There's a very small margin. Okay, but the point is, the detectors, these detectors can collect the data, they can transmit the data, and they can be used with other devices of the road. Okay, so those devices can operate on real-time data, what is happening right now. This is a handbook which deals only with traffic detectors. Okay, portable and permanent, both of them. Which type of technologies are used in the detectors, or what type of detectors we have? We have sound detectors. So whenever a car passes, the noise level or the sound level in that vicinity slightly increases because of the tires, because of the engine, and so on. Okay, so there are detectors which can detect this increase in the sound, and then they record it as a passing of the vehicle. Okay, so we call them sound or acoustic detectors. Then we have opacity detectors as well. Opacity detectors are those which are detecting data from an image or a video. So they are like cameras. Okay, they are like cameras, like the speed cameras we have. Okay, so the main function is the detector is looking at the image or video of the road, and from that it is extracting how many cars are passing or what is the speed of the vehicle and so on. Clear? Okay, and these images can be of different types. Okay, you can have the normal image, the colored image we have. You can have the infrared image. Okay, and you, like we have the, when you go for the X-ray, what is an X-ray machine? It's a camera, right? It works like a camera. It gives you an image. Okay, but not the image you want to look at, right? So it's a different type of image. So images can be different. We have thermal imaging and infrared imaging and so on. The images can be different, but the principle is same. That it's taking an image, some sort of image from the road, and it is processing the data from the image. Then we have magnetic detectors. Okay, so the detectors creates a very light magnetic field around it. The car passes, the magnetic field is disturbed. So the number of times the field is disturbed, it is the count of the vehicles. Then we have the detectors which work on reflected or transmitted energy. So these detectors have two parts. One is a transmitter, the other one is a receiver. And we put them on different edges of the road, different sides of the road. Okay. So this one is transmitting energy, this one is receiving it. When the car passes or the vehicle passes, what will happen? This connection will break, right? This will intercept. Okay. So the time for which this connection is intercepted can give you the speed, it can tell you about the size of the vehicle. Okay, and the number of times the connection is intercepted is the number of vehicles you have, okay, on the road. You have used something similar to this where?
Survey.
In surveying. Okay, so the electronic equipments, the electronic, the digital level, the electronic theodolite, the total stations, they all work on the same principle. And I don't know why I still remember. Then we have the one which works on electromagnetic induction. We call them the loop detectors as well. Okay, because they have two parts actually, or they look like they are something like this. Okay, so they have two parts. So this is your highway, you're going in this side. Okay, so you go over this part and then this part. So it forms like a loop for the detector. This is the same vehicle passed from here and then here. They call them loop detectors or inductive loop detectors. They are very commonly used on the intersections. They are put under the road. Okay, they are under the pavement. Okay, and they can give you speed and counts. Then we have vibration detectors. They are again put under the road. Okay, under the pavement, and you can feel whenever a car passes, there's a little bit of vibration. Okay, which is caused to the surface of the pavement. Okay, if you are standing on the side of a bridge, you can feel it very clearly. Okay, because the bridge is in the air, so the vibration is more. But even at the ground level, there is a little bit of vibration. So these detectors can sense this vibration and they can record the traffic data according to it. Okay, then we have the VIP. Who is the VIP?
You.
Yes. Okay. Anybody else? Yeah. What? VIP means what?
Very important person.
Very important part, right? Okay. That's what it means, right? It means this outside the class. Okay. Inside the class, it means video image processing. Got it? Not me. Video image processing. Okay. So it's an entire system. Okay. Video image processing is an entire system. Obviously, we are talking about video, so this system must have a camera. Okay. And camera is doing what? It is taking video from the road, right? Okay. It's taking video from the road. So the location of the camera is very important. Okay. So establish this system. The first thing you have to worry about is the location of the camera. Okay. The best view is the one from the top front. Okay. The camera should be somewhere on the top. It should be looking at the road from the front, not from the side, from the front. Okay. So if you have a pedestrian bridge, for example, so you can put the camera under the pedestrian bridge with the beam or with the column or something. Okay. The other bridge as well, the concrete bridge, you can put the camera with the pair of the bridge. Okay. There are some signals. You have seen there is a signal pole, and the lights are like this, horizontal. Okay. So this is called the hand or the mast of the signal. This is also a good location to put the camera. Okay, because again front and on the top. Okay. Usually these are higher. The normal signals, the vertical ones are lower. This one is higher. Okay, the one which is like this is higher. So it becomes a good location for the camera. You can focus the camera on one lane, you can focus the camera for one direction, you can focus the camera for the entire road, as you like. Okay, so this is an advantage. In addition to the camera, what else do we need? We need a microprocessor which can store the images, which can interpret the images. Okay, we need a memory chip, we need a processor which can record the video and so on. Okay, so we need some processing mechanism in that one as well. And then we need the software which can capture the data from the image, from the video. Okay, so the camera is giving the video and the processor is recording it. Then we need some software, some application, some code which can capture the traffic data from the video. Okay, some people do it manually, like most of the students in the term project, or many students in the term project, they do it manually. So they record the video, then they sit in front of the screen and they count and take the speed manually. Okay, but there are many programs and softwares available even in MATLAB. Okay, so image processing and video processing is now very, very common. Okay, and there are some other open source programs available as well in Python and C++ and so on and so forth. Okay, so people are already doing it. Okay, so then you let the video play in the program, and once the video is finished, you have your count. You play it and you go wherever you want to go. You don't have to sit in front of the screen for hours. Okay, so that is the main advantage of the software. Okay, I had a couple of students 1 year ago. They generated their own code according to them. They generated their own code for counting of the cars from the video. Okay, so people do that. Okay, but like I said, even if you don't know how to code, the codes are available. Okay, but the problem with the code or the software is you have to train it. Okay, you have to tell the software which one is a car, which one is a bus, which one is a truck. Okay, so because the software is just looking at the group of pixels in the video. Okay, this screen is a group of pixel, this chair is a group of pixel, I am a group of pixel. It's all the same for the software. You have to tell the software when the pixels are of this size and this shape, this makes a person. And this shape and size makes a car, and so on. You have to do some training of the software, okay? And the things which you have to keep in mind, if you are taking your picture, okay, what is the most important thing here for taking a good picture? Quality. How does the quality change? I'm not talking about the camera. Not talking about the camera. The lights. Okay, the lights. So this will work outside, right? Open air. So we cannot control the lighting conditions. Lighting conditions change in the whole 24 hours, right? Okay. Some locations have street lights. Some locations don't have street lights. Okay. And even with the street lights, the lighting condition early in the morning and in the afternoon it's completely different. It's daytime, so lights are not working, but the light conditions are changing. Got it? So you have to train the camera or the software to detect the image in different lighting conditions. This is one thing. Second thing is you have to train the software to filter the objects. All objects are not to be counted. Okay, the road may have a big trash can. Okay, which may be of the same size of a small car, but we don't want to count the trash can, right? Okay, or the road may have some other objects which we don't want to count. Okay, so using the VIP system, the software needs to be trained for different road conditions, especially the lights, and you have to train the software to classify between different objects so that it does not count the irrelevant objects. Your computer will destroy them. Okay. So according to the book, I have not seen it, but according to the book, these cameras or these systems are used at some of the signals. Okay, so it's from US, so they are talking about there. So they are used with signal systems. The camera captures the image, the software processes the image real time, and then the data is transferred to the signal. The signal works according to the real time data. Okay, and they are saying it will become popular. I don't know when. Okay, and this is a video of one of the examples of how the camera works. Okay, with the signal. Okay, you can go and have a look. This is it. We will start the new topic on Thursday, inshallah. Any questions? Any problems?